Okay, mass storage systems will be the last chapter of this course. In this chapter, we discuss how mass storage, the non-volatile storage system of a computer, is structured. The main mass storage system in modern computers is secondary storage, which is usually provided by hard disk drives or HDDs and non-volatile memory NVMe devices. Some systems also have slower, larger tertiary storage, generally consisting of magnetic tape, optical disks, or even cloud storage. We first describe physical structure of secondary storage devices. We then consider scheduling algorithms which schedule the order of input outputs to maximize performance. The bulk of secondary storage for modern computer systems is provided by hard disk drives and non-volatile memory devices. Conceptually, hard disk drives are relatively simple. Each disk platter has a flat circular shape like a compact disk. A read-write head flies just above each surface of every platter. The heads are attached to a disk, actually attach the disk arm that moves all the heads as a unit. The surface of a platter is logically divided into circular tracks, which are subdivided into sectors. The set of tracks get a given arm position make up a cylinder. There may be thousands of concentric cycles in a disk drive, and each track may contain hundreds of sectors. Each sector has a fixed size and is the smallest unit of transfer. A disk drive actually all disk drives has motors. A disk drive motor spins it at high speed. Most drives rotate 60 to 250 times per second, specified in terms of rotations per unit. The transfer rate is the rate at which data flow between the drive and computer. Another performance aspect, the positioning time or random access time, consists of two parts: the time necessary to move the disk arm to the desired cylinder, called the seek time, and the time necessary for the desired sector to rotate to disk head, called the rotational latency. Although the disk platters are coated with a thin protective layer, the head will sometimes damage the magnetic surface. This accident is called a head crash. A head crash normally cannot be repaired. The entire disk must be replaced, and the data on the disk are lost unless they were backed up to other storage or RAID protected. Here you can see the moving head disk mechanism. We have platters, we have tracks, we have an arm for every head, and actually this concept can be described as the moving head disk mechanism. Non-volatile memory devices are growing importance. Actually, we are using SSDs on our personal computers mostly. Simply described, non-volatile memory devices are electrical rather than mechanical. Flash memory-based NVMs is frequently used in a disk drive-like container, in which case, in that manner, we call them as solid-state disk or SSD. In other instance, it takes the form of USB drive, also known as a thumb drive or flash drive or a DRAM stick. It's also surface mounted onto motherboards as the main storage in devices like smartphones, etc. In all forms, it acts and can be treated in the same way. Our discussion of non-volatile memory devices focuses on this technology. We are going to move with the hard disk scheduling because the algorithms we are going to focus on will be parted here. As you can guess, one of the responsibilities of the operating system is to use the hardware efficiently. For HDDs, meeting this responsibility entails minimizing access time and maximizing data transfer bandwidth. For HDDs and other mechanical storage devices that use platters, access time has two major components. The seek time is the time for the device arm to move the heads to cylinder containing the desired sector, and the rotational latency is the additional time for the platter to rotate the desired sector to the head. The device bandwidth is the total number of bytes transferred divided by the total time between the first request for service and the completion of the transfer. We can improve both the access time and the bandwidth by managing the order in which storage I/O requests are serviced. Whenever a process needs I/O to or from our drive, it issues a system call to operating system. The request specifies several pieces of information, including whether this operation is input or output, the open file handle indicating the file to operate on, what the memory address for the transfer is, and the amount of data to transfer. So please note that driver controllers have small buffers and can manage a queue of I/O requests. Several algorithms exist to schedule the servicing of a disk I/O request. We are going to illustrate some scheduling algorithms with a request queue from 0 to 199. And actually, in this case, we're assuming our borders, our range is from 0 to 199, and this is our request list. Actually, that means we can consider them as locations. We can move between 0 to 199, and based on that, we have some requests to service. Also, we're assuming that we have a head pointer pointing some location. In our examples, the initial location will be 53, and starting from that location, we are going to find a path. We are going to find a sequence to service all these requests. The simplest form of this scheduling is, of course, the first come, first served algorithm. It's very similar to first in, first out. This algorithm is fair, but it generally does not provide the fastest service. Consider, for example, a disk sequence here. Our head starts at this location, and based on the queue, based on the first come, first served process, we are going to move the head from initial point to 98, then 183, then 37, then 122 and 14, etc. So based on this list, we are going to serve the requests as first come, first served. So based on the movement from these points, we can find the total movement of our head, and based on that, we can compare different algorithms. So this is how first come, first served algorithm works, and this illustration actually shows that the total head movement of cylinders will be 640 based on that, because we are going to start this point and we are going to serve the requests as come order, and that means we have a total 640 cylinder movement as our head. The next one is scan algorithm. In the scan algorithm, the disk arm starts at one end of the disk and moves toward the other end, servicing requests as it reads each cylinder until it gets to the other end of the disk. At the other end, the direction of head movement is reversed and servicing continues. The head continues to scan back and forth across the disk. The scan algorithm is sometimes called as an elevator algorithm, since the disk arm behaves just like an elevator in building, first servicing all the requests, going up, and then reversing to service other way. And here is the example. Again, we need to know that the queue and the starting point at head. Also, we need an additional information here. We need to know the head movement direction with the head's current position. We know that the current position, the initial position is that, but also we need the information which way already the head is moving. In this case, we are assuming that, okay, the queue is the same, the head still starts from the 53, and also we're assuming that the disk arm is moving towards 0, that the initial head position. So based on the scan algorithm, we are going to move from the initial condition to one way, because we know that head is already moving that way. While we are moving from initial condition to 0, we are going to service the requests on the path. Here I have a service, I have a request, so I can serve it. Here I have a request, I can serve it. And then I'm going to reach the 0. After that, we are going to change the direction and we are going to move from 0 to 199. So based on that, we are going to make a scan on our disk. And again, you can find the total number of head movements by getting sum of the every movement based on that locations. The other one is circular scan or C-scan. C-scan scheduling is a type of scan designed to provide a more uniform wait time. Like scan, C-scan moves the head from one end of the disk to the other while servicing the requests along the way. However, when the head reaches the other end, it immediately returns to the beginning of the disk without servicing any request on the return trip. Here again, we need to know the direction of head movement in which the requests are scheduled. Here we are assuming that the controversy of the previous example, we are assuming that our head is moving toward to 199. Again, our head is starting from this point, our queue is the same, so the movement way is that way. We are going to serve the requests along our way from initial point to 199. But when we reach here, instead of returning with service, we are going to immediately return the other end without any servicing. And then we are going to continue to serve requests on the same way again. So this is the difference between scan and circular scan. On the scan, okay, you move from one end to other end, but while moving, you have to serve the requests. But on the syscan, you are going to serve the requests only just one way. When you reach the other end, you are going to immediately return to 0 and you are going to serve the requests again. So these are the difference between scan and syscan algorithm. And that's it. Kimse olmadığı için sorusu olan var mı demiyorum. Ama şunları söyleyeyim. Nasılsa soracaksınız sınavla ilgili. Vizeye benzer olur. Daha fazla algoritmadan bahsettik. Özellikle bugün bahsettiğimiz page replacement algoritmaları ve biraz önce bahsettiğimiz disk scheduling algoritmaları önemli. Bunlardan kesinlikle sorarım. Onun dışında diğer meselelerden de sorarım. Hani kesin olarak söyleyeceğim bir şey yok ama bu iki tür algoritmadan kesinlikle birer tane soru sorarım. Page replacement algoritmalarında size bir string veririm, frame sayısını veririm. Şu algoritmayı kullanırsanız kaç tane page fault'la karşılaşırsınız derim. Burada da yine size bir string veririm. Nereden başladığını veririm. String'den kastım bu request queue. nereden başladığını head pozisyonunun veririm. Eğer scan ya da scanse yönü veririm ve sizden toplam kaç silindirlik head movement yapıldığını hesaplamanızı isterim. Onun dışında dediğim gibi vizeye benzer olur genel olarak. Net olarak söyleyebileceğim başka bir şey yok. Görüşmek üzere, hoşça kalın, başarılar diliyorum.